Morning, guys. Today I want to explore our options a little bit further in views for technical drawings and multi-view drawings. What I want to go over is auxiliary views and what they're used for and the reason we do. We know that we use multi-view drawings to give us a true perspective for dimensional purposes. These auxiliary views are added to a standard multi-view drawing. An auxiliary view is an orthographic projection of an angled surface, which appears foreshortened in a typical multi-view drawing. Auxiliary views are used to show the true size and the shape of an angled surface and its features. And when you guys had to actually sketch some of those wooden blocks, you were looking at angled surfaces, and sometimes you had to draw them as a square or a rectangle in one view, but then in the other view you could see that it was an angle. But both views, you were not looking at the angle directly straight on, and that becomes important for the people who make things, build things, put them together. The guy who drills the holes, the welder, the carpenter, the person who is actually building it, who can't see your design. It's important for him to be able to know where to put that center mark for that hole and where to drill it. Foreshortened surfaces on multi-view drawings don't give a clear or accurate representation of the size of the shape, and they shouldn't be dimensioned that way. So you need to create an auxiliary view that somebody can dimension from. On these two bottom ones, you see that those are angled positions, and they would be very difficult to draw a dimension to. So an auxiliary view would allow the viewer in the top view to look perpendicular to that angled surface to witness the true size and the shape of that surface and its features. In this case, it's a hole. All right? So this one here in the middle is an auxiliary view of the top view in this condition turned perpendicular so that you can see a realistic view of where the center of that hole is. You'll notice that you only see one hole. It's because it's looking straight on through it. It's the true height. It's the auxiliary distance. And there are three types of ordinary auxiliary views. It's the depth auxiliary, height auxiliary, and width auxiliary. Now, what three dimensions do we normally have? We have depth, height, and width. So those are the three auxiliary views that we have. Should they ever come up in a question of any sort, some sort of assignment with questions, there's three types of auxiliary views. What are those three depths? Depth, height, and width. A depth auxiliary view is derived from a front or back view of an object, and it'll show the true depth. Width auxiliary view is derived from the side of an object, and it'll show the true width. Hence the name, width auxiliary. Height auxiliary is derived from the top or the bottom of an object, and it'll show the true height. To create one, you start with a multi-view drawing of an object that contains a canted or angled surface. In this case, the canted surface for which the auxiliary view will be created is shown as an angled edge in the front view. All right. So looking at this auxiliary view, this is one of those ones that has multiple angles, and it shows different angles and shows squares from different views. Okay, we've got points 1 through 6 here, and in the top view we have 1, 2 and 9, 3 and 8, 4 and 7, and 5 and 6. These dual numbers 5, 6, 4, 7, 3, 8, 2, 9. Looking down from the top, you will see that 2 and 9 stack on top of each other. Same thing with 3 and 8. They're stacking on top of each other. Okay? And the same thing with the other views. All right? So you've got to determine next which true dimension will be shown by the auxiliary view and identify the reference edges on the proper existing view. You're going to draw appropriately spaced construction lines where the auxiliary view will occur. And these construction lines, just like when we did with the multi-view drawings, will serve as a reference lines, and they must be parallel to the angled edge in question. So the edge of this reference plane here is this reference line here. This reference line here would be there. Those three lines referenced off of here, you are able to draw the adjoining lines. Draw construction lines outwards from each corner of the view from which the auxiliary view will be a 90-degree rotation. The lines must be perpendicular to that angled edge in question. Identify the relationship between the corners of the objects and the intersections of the construction lines, and then draw directly up to them. Then you would fill in your object lines. Draw the object lines to connect the corners that share visible edges. So you then have the auxiliary view. This auxiliary view, as projected from the front view, shows the true size and true shape of one of the angled surfaces. The other two surfaces here and here are distorted. If a feature such as a hole were located on this surface, it could now be properly dimensioned. So what you see in the red is the true perpendicular view of the surface, which is the one that we are concerned with for being able to measure and identify certain points on that, as if there was, we'll say there was a hole there. And I would have put one in this PowerPoint had I created it. Partial views. Foreshortened objects may have complex shapes or curves that can be difficult to draw. So a short break lines and partial views may be used to remove the needed to draw the difficult curves on foreshortened faces, while still maintaining the complete shape description and so forth within that multi-view. So rather than drawing all of this here, you could do a partial view just to get the angled surface with the round hole, because the top view has the true view of the slot. But in the top view and from the side view, you're both going to get, both of those views are going to have a distorted view of the round hole. So creating a partial view rather than drawing the whole elaborate item on here, we just need the part to locate the center of that hole in the view. And here we see pointed out the short break lines. Okay. The big thing to identify, be able to remember in this PowerPoint is to remember the three different types. What are they? Height, width, and depth. And they would show the true view. Okay. Excellent.